Good morning, my dear students. So yesterday we discussed about maximum likelihood estimator. So we have seen two examples also. So today we continue with some more examples. So maximum likelihood estimator is a very important concept in statistics. Many of the examinations, not even examinations, even in real life also, MLE having a more importance in statistical inference. Okay, right. We will continue yesterday's definition maximum likelihood estimator with some more examples. Take it next example. Let x1, x2 and so on xn be a random sample of size n from Bernoulli population with parameter p. Then find its MLE, maximum likelihood estimator. Solution. See here, sample values x1, x2 so on xn. Here parameter p, and we need to find MLE for the population. These are the main things. Here parameter is p, we need to find MLE, and our population is Bernoulli population. See, either Bernoulli population or binomial or Poisson or exponential. First we need to write probability function. Okay, let x be a Bernoulli random variable. Bernoulli Bernoulli random variable. Then its probability mass function, because Bernoulli random variable is discrete, is probability of x equals to e power x q power 1 minus x equals to 0 comma 1. P lies between 0 and 1. Even for the convenience, we can take 1 minus p whole power 1 minus x, because here p plus q equals to 1. Probability of success, probability of failure, both sum should be equals to 1. So q becomes 1 minus p or p becomes 1 minus q. I just replace q by p because we need to find maximum likelihood estimator for p. So everything we need to express in terms of p only. Now likelihood function. This is this one. So next we go for likelihood function. L of parameter p is nothing but I equals to 1 to n. Yeah, either p or f, anything. Probability function. So yeah, you can write it p only. Xi comma p. See, the way how we did for Poisson distribution or exponential distribution, the same thing will appear here only. But only thing is probability functions may change. The remaining procedure, everything is same. Okay. Product over I equals to 1 to n. What is our probability function? This one. P power x 1 minus p whole power 1 minus xi. We need to write xi. Instead of x, we need to write xi. So that means e power xi 1 minus p power 1 minus xi. Now if you see p power, first you keep I equals to 1 and then continue. 1 minus x1 into p power x2 1 minus p power 1 minus x2. This is x1 and so on. E power x1 1 minus p whole power 1 minus xn. Now after simplification, you know everything, no need to explain every time. Summation xi x1 x2 and so on xn, and this one 1 minus p. How many ones are here? N ones are there. So if we sum all those n ones, then we will get n minus x1 minus x2 minus and so on minus xn. That becomes summation xi. This is L of p. And next step is what? Take logarithm. Take logarithm on both sides. Take logarithm on both sides. Then what will you have? Log of L of p equals to log of p summation xi 1 minus p whole power n minus summation xi. Just do little bit calculations. Now I am going to write here log of L of p equals to, what is here? Log of p power summation xi. So p power n, that means log a, sorry, some log x, log x power a log x, a log x. So in this manner we can expand it. So that is summation xi log p plus n minus summation x pi log 1 minus p. N minus summation xi log 1 minus p, summation xi log p, log a power m, m log m, m log a, in such a manner. Now differentiate. Now differentiate partially with respect to p. So dou by dou p of log of L of p equals to dou by dou p of summation xi log p n minus summation xi dou by dou p of log of 1 minus p. Because this is constant, we can take it outside. So summation xi is constant. Summation xi dy by dx of log x is 1 by x. So 1 by p plus n minus summation xi into this becomes 1 by 1 minus p. This becomes 1 by 1 minus p. Again we need to differentiate this one. So you will get it, sorry, you will get it minus 1. Now equate dou by dou p of log of L of p equating to 0. You equate this one to 0. What it is? Summation xi by p, here minus 1. So you will get it minus n minus summation xi by 1 minus p. You just equating this one to 0. You equating this one to 0. Next, what will you get it? P into 1 minus p is the LCM. 1 minus p into summation xi, cross multiplication, and then minus p into n minus summation xi equals to 0. Yeah, do the simplifications. I am going to do the simplifications. 1 minus p into summation xi minus p into n minus summation xi by p into 1 minus p equating to 0. That implies, see, numerator divided by something value. So this should be 0 only when numerator becomes 0. That means 1 minus p summation xi minus p into n minus summation xi equals to 0. I am just taking multiplications. Summation xi minus p summation xi minus p into n minus minus plus p into summation xi equals to 0. this one gets cancelled, and if you go here, summation xi minus pn equals to 0. That means pn equals to summation xi, n equals to summation xi, sorry, p equals to summation xn by n. That means p equals to x bar. Therefore x bar is a MLE of maximum likelihood estimator of parameter p of a Bernoulli population. Bernoulli population. Okay, yeah, this is about Bernoulli distribution. Then we will move to another distribution, that is binomial distribution. Next we move to binomial distribution. Is it clear, right? Yeah. Next question. Next example. Let x1, x2 and so on xn be a random sample of size n from binomial distribution b of m comma p, not n, because here we already taken n, so you just make it here m. Okay, size n from binomial distribution b m comma p. Then find maximum likelihood estimation of p. Solution. Okay, just try చేయండి. binomial distribution function రాస్తాను, ట్రై చేయండి. Let x be a binomial with m comma p, then its PMF, probability mass function, is given by probability of x equals to mcx p power x 1 minus p power m minus x equals to 0, 1, 2, 3 and so on m. 0 less than p less than 1 are the limits. ఇప్పుడు ఇది ఫంక్షన్ చెప్పాను. Now write down likelihood function. Likelihood function L of p is given by L of p equals to product over I equals to 1 to n p of xi comma p. Yeah, I am giving you 1 minute of time. You just try it. From here onwards, how will you proceed? Okay, proceed. I am going to give you 1 or 2 minutes time and I will see. Okay, we will see. We will continue. So L of p becomes product over I equals to 1 to n mc. First you, in place of x, you just write xi, p power xi 1 minus p power m minus xi. Okay, mc x1 p power x1 1 minus p power m minus x1 into mc x2 p power x2 1 minus p power m minus x2 into and so on into mc xn p power xn 1 minus p whole power m minus xn. Now this is constant with respect to p. With respect to parameter mcxi's are constant. So all these products you just write as it is in the notation only. Product, okay, p power. So p power summation xi, p power x1, p power x2 and so on, p power xn. So p power summation xi. Next 1 minus p m minus x1. How many times m repeating here? N times, m plus and so on, m you will get it. So n into m. Next minus x1 minus x2 and so on minus xn. That is nothing but minus summation xi. This is L of p. Now take logarithm on both sides. Take logarithm on both sides. Log of L of p equals to log of product over I equals to m to n xi p power summation xi 1 minus p power n into m minus summation xi. After expanding we will get it log of product of I equals to 1 to n mc xi plus I am taking logarithm log a power m also I am applying directly. Log of abc, log a plus log b plus log c. Again I am applying log a power m log a. So both I am writing in a single sentence. Plus n, okay, n into m into n minus summation xi into log 1 minus p. Now take differentiation. Take differentiation with respect to p. We get, so ఇది log of L of p. దీన్ని p తో డిఫరెన్షియేషన్ చేస్తే right, dou by dou p of log of L of p equals to dou by dou p of log of product over I equals to 1 to n mc xi plus dou by dou p of summation xi log p and then dou by dou p of m into n minus summation xi. Sorry, we will write clearly. M into n minus summation xi log of 1 minus p. This is constant with respect to p, so we will get it 0 plus summation xi is constant 1 by p. Next m into n minus summation xi, this is constant, and log 1 minus p is 1 minus p. If again we do 1 minus p with the derivative, then we will get it minus 1. Now equate dou by dou p of log of L of p. Now equate to equate to 0. We get 0 ki equating cheste em vastundi. That means dou by dou p of log of L of p equating to 0. That implies That implies equating to 0 చేస్తే summation xi by p plus and minus 1, we will get it minus mn minus summation xi by 1 minus p equating to 0, equating to 0. Then we have cross multiplication and then do simple LCM. 1 minus p summation xi minus p into mn minus xi by p into 1 minus p equating to 0. That implies numerator should be 0. That is 1 minus p summation xi minus p into mn minus summation xi equals to 0. Equals to 0. Just do the calculation. Summation xi minus p summation xi minus p into m into n plus p into summation xi equals to 0. Minus p summation xi plus p summation xi gets cancelled. That implies summation xi minus p into m into n equals to 0. That means, that implies p into m into n equals to summation xi. P equals to summation xi by m into n. Here summation is I equals to 1 to n. I equals to 1 to n. This part becomes x bar. This part becomes x bar. So p equals to x bar by m. Therefore MLE of parameter p of binomial distribution is p cap equals to x bar by m. X bar by m. X bar by m. This is MLE. P cap is x bar by m, where x bar is summation xi by n, sample mean. X bar by n. Any doubt here? Any doubt in these calculations? Very similar calculations, simple calculations. Most of the problems having a same set of instructions and derivative, almost every problem in this manner only. Next we go for one more example that is most powerful and important in statistical area. Next example. Let x1, x2 and so on xn be a random sample of size n from a normal population with parameter mu and sigma square. Then find MLE of first one, mu when sigma square is known. Second case, MLE of mu when sigma square is known. That's the first part. Second part, sigma square when mu is known. When mu is known. Okay, we go for solution. Okay, first we need to write a probability density function. So let x be a normal random variable with mu comma sigma square. Then its probability density function is given by f of x comma mu comma sigma square ఎలా ఉంటుంది 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square mu by sigma whole square mu by sigma whole square. Yeah, sure. Next, likelihood function. Consider likelihood function. So what are the parameters? Mu comma sigma square is becomes L of mu comma sigma square equals to product over I equals to 1 to n f of xi comma mu comma sigma square f of xi comma mu comma sigma square. Now what we do is just write down the function product over I equals to 1 to n. In place of x you write xi, that means 1 by sigma root 2 pi e power minus 1 by 2 xi minus mu whole square by sigma square I am writing outside. Sigma square I am just writing, see here 1 by sigma whole square. Here I just written denominator separately. Okay, that's all. Now expand it through I equals to 1 to n. Then we'll see what it becomes. 1 by sigma root 2 pi e power minus 1 by 2 x1 minus mu by 6 whole square into, see in place of I just put I equals to 1, and then next 1 by sigma root 2 pi, because here it's looking in a constant function, e power minus 1 by 2 x2 minus mu whole square by sigma square into, and so on. 1 by sigma root 2 pi, see here xi I equals to 1 to n, so this one only becomes changed, remaining all will become the same value only. 1 by sigma root 2 pi e to the power of minus 1 by 2 xn minus mu whole square by sigma square, all these things in the power of e. Okay, here 1 by sigma root 2 pi whole power, how many times you are multiplying this one? Same value, n times. Then what about here? E to the power of minus 1 by 2 x1 minus mu whole square by sigma square minus 1 by 2 x2 minus mu whole square by sigma square, all are adding. So first you look at what are the constant terms, you just take it outside. Common term is 1 by 2 sigma square, 1 by 2 sigma square, 1 by 2 sigma square is common. So remaining all are summations. So we can write simply, e to the power of minus 1 by 2 sigma square is a common term, and remaining all are summations. That means summation I equals to 1 to n xi minus mu whole square, xi minus mu whole square. This we need to simplify it. Take logarithm. This is L of mu comma sigma square. Take logarithm on both sides. Take logarithm on both sides. Take logarithm on both sides. That is log of L of mu comma sigma square equals to log of 1 by sigma root 2 pi whole power n, 1 by sigma root 2 pi whole power n. So plus log of log AB, log A plus log B. I am expanding directly. So log A plus again this log and exponential 1 by 2 sigma square summation I equals to 1 to n xi minus mu whole square. Next it becomes see, look at here, AB whole power m, that means 1 by sigma is there and root of 2 pi and everything. So what I am writing, this one is log of, see, we need to find MLE for sigma square, not for sigma. So write sigmas also in terms of sigma square. That means sigma square whole power 1 by 2. Whole power 1 by 2 means root. Both are same, but we are expressing sigma in terms of sigma square just for the sake of mathematical. This one also 2 pi whole power 1 by 2 whole power n. Log and exponential gets cancelled, then you will get it 1 by 2 sigma square summation I equals to 1 to n xi minus mu whole square, 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 log of 1 by sigma square whole power n by 2 plus log of 1 by 2 pi whole power n by 2, because 1 by a whole power n is 1 by a power n. 1 by a power n. Here 1 by 2 is there. So n by 2. Here 1 by 2 is there. N by 2. Minus 1 by 2 sigma square summation I equals to 1 to n xi minus mu whole square. Log 1 by x or log 1 by a. Log 1 by a equals to minus log a, or simply log a by b, log a minus log b. Here in place of a, what we have it? A equals to 1. Then what is log 1? 0. So minus log of sigma square whole power n by 2. Whole power n by 2. See, 1 by a whole power n is 1 by a power n. Log of a by b is log a minus log b. Here a equals to 1. Here we have 1. Log a minus log b. You will get it log 1 0. In the same way, minus log of 2 pi whole power n by 2. So this is rough work. So this one minus 1 by 2 sigma square summation I equals to 1 to n xi minus mu whole square. This is log of L of mu comma sigma square. Log of L of mu comma sigma square. Some more simplification is there. Log a power b, b log log a power m, m log a. So minus n by 2 log of sigma square minus n by 2 log of 2 pi minus 1 by 2 sigma square summation I equals to 1 to xi minus mu whole square. This is log of L of mu comma sigma square. Take it equation number 1. Take it, that is equation number 1. Now for what parameters we need to find the MLA? Go to the question. Mu when sigma square is known. Now we will take case 1. Now consider case 1. Case 1. MLE of mu when sigma square is known. You know sigma square value. Then that becomes constant. Okay. Now we need to find for mu. Then what we need to do? Take logarithm on both sides of equation 1. Take logarithm on both sides of equation 1. Okay. Sorry. Not logarithm. Sorry. Take partial derivative on both sides with respect to mu. Mu కావాలి కాబట్టి mu తో partial derivative చేయాలి. That means dou by dou mu of log of L of mu comma sigma square. So dou by dou mu of minus n by 2 log of sigma square dou by dou mu of n log of 2 pi minus dou by dou mu of అక్కడ ఏముంటే అది రాసేసేయండి minus 2 sigma square summation I equals to 1 to n xi minus mu whole square. Xi minus mu whole square. Xi minus mu whole square. Okay, right. Minus then minus n by 2 log kada. Right. When you are doing partial derivative with respect to mu, then this becomes 0. When you are doing partial derivative with respect to mu, this is also constant, so this is also becomes 0 minus. When you are doing with mu, here we will have a function, so minus 1 by 2 sigma square is we will make it aside and then do differentiate this one with respect to mu. X square d by dx 2x d by dx of x minus a whole square, that is 2 into x minus a. In the same way you are dealing with this mu, so summation as it is, it will come, so 2 into xi minus mu. Again we need to do with minus 1. Again we need to do differentiation of with respect to mu. We will get it here minus 1 because here mu having minus symbol, so you will get it minus 1. So dou by dou mu of log of L of mu comma sigma square equals to minus minus gets plus 1 by 2 sigma square summation I equals to 1 to n. Okay, 2 gets cancelled. Sorry, here 2 gets cancelled, so xi minus mu, yeah, this one only, minus minus plus and 2 gets cancelled, sigma square will become in the denominator. Now what we need to do? Dou by dou mu of log of L of mu comma sigma square equating to 0. That implies 1 by sigma square summation I equals to 1 to n xi minus mu becomes 0. This is 0 only when this becomes 0, because 1 by sigma square never equals to 0. So this should be 0. That means summation I equals to 1 to n xi minus mu equals to 0. Summation xi minus summation mu equals to 0. This is summation xi. How many times you are adding mu? N times. So n times you are adding mu constant. So you will get it n into mu equals to 0. That implies n into mu equals to xi. Mu equals to summation xi by n. That is x bar. Therefore MLE of mu is mu cap is x bar. That's all. Is x bar. So this is MLE of mu of a normal distribution. That is MLE of mu is sample mean x bar. Next case is what? This one, sigma square when mu is known. Now we need to find for sigma square, not for mu. Okay, comes to log likelihood function. Where is equation number 1? This one. Now what we need to do here? Case 2. Here we have done case 1. Next we need to go for case 2. What is that? MLE of sigma square when mu is known. If that is the case, we need to do partial differentiation of 1 with respect to sigma square. Okay, we'll see. No problem. I will write it here. I know the equations. Okay, case 2. What is case 2? MLE of sigma square when mu is known. When mu is known.